In this lesson, we're going to talk about two different domains within the kindergarten standards. We're going to talk about counting and cardinality, and then operations and algebraic thinking. Um, but first, I wanted to talk about why are we using manipulatives. There's three different stages that children go through when we're learning something new, and ideally, we're going to start with manipulatives in the concrete stage. And we use manipulatives in the concrete stage as a way to introduce concepts, and children are able to explore and develop their own ideas before we start giving them algorithms. So they're able to identify patterns and see how things work, make their own justification first. Then we're going to move on to the representational stage, where we're going to use pictures to replace concrete objects. So children can now demonstrate visually and communicate their ideas at a picture level. And then finally, as children get older, almost in the more middle school age, we're going to use symbols like numerals, operation signs, and variables so that children can now demonstrate their understanding of math concepts using actual math language. So all three of these stages are important to the learning. So with counting and cardinality, and with any of the grade levels that we're going to talk about, there are an infinite number of ways in which we can incorporate manipulatives into kindergarten math, first grade math, second grade math, etc. The more that we can incorporate a variety of manipulative ways, the more ways we'll be able to show a larger magnitude of these representations so that students have an opportunity to choose a way that makes sense to them. Students need to develop a strong number sense by being able to relate numbers visually, verbally, and in written form. So some common manipulatives that are used in counting cardinality are objects for counting. These could be little number bears, coins, little figurines, anything that they can count. We're going to use 5 frames and 10 frames, hundreds charts, dot cards, and numeral cards. So this is the domain here for counting and cardinality. Students need to know number names and the count sequence, count to tell the number of objects, and then compare numbers. I'm going to go through each of the specific standards and note that many of the techniques that we're going to talk about cover a variety of different standards, not just one in particular, which is awesome as well. And then it also jumps between domains as well. So let's start with our hundreds chart. Students need to be able to count from 1 to 100 by the time they leave kindergarten. They need to be able to count by tens. They also need to be able to count forward and backward from any given number. Students should be counting every day in a variety of different ways. Some common questions to ask might be, what number comes after 4? What number comes after 55? Or what number comes next? So if we stopped at 38, what number comes after 38? What number comes before 38? Count backwards 3 spaces from 46. Count forward 5 units from 51. And simply you would just sit in front of a classroom and you would just go through a series of questions every single day until students almost have it memorized. Students should also be writing their numbers every day. Remember that you have all year to master all of these different standards. So don't feel overwhelmed by the standards that you need for language arts, for reading, for art, whatever the standards that you're following, you have all year to accomplish them. So start small. Don't overwhelm the students at all. So start with a single number at a time and gradually build. So start with the number 0. Start writing that every day, practicing it. When students got it, then work with 0 and building on to 1, and so forth. Some great activities to bring everything together. So some great manipulatives for counting. On the top left corner, you see we have number dots with numeral cards. You can use clothespins to represent 3. So they see the numeral 3, they see the dot representation, and then they're building 3 themselves. They're using little puff balls for the number 5. We see the numeral 5. They're placing the puff balls on the dots, so they're connecting the two together. Similarly with the glass beads, we have the number cards with the dot cards, and they're building their own so they can see how many. On the bottom left and on the top right here, we see we have tens frames, and we're going to get to tens frames here in a second on what that means. But notice that they're building numbers by seeing numbers, organizing numbers with chips, with clothespins, with glass beads, etc. So some common questions you might ask students: what number is this? Show me this many fingers. How do you know how many fingers to hold up? Is there another way we can show, let's say, for example, the number 5? On the bottom left here, we've got 5 dots, and then we have 5 chips lined up along the top. Is there another way we can show 5? So maybe they might bring the puff balls, etc. So asking and repeating the same questions, just asking differently and about different properties of numbers, is key to kindergarten. 10 frames may be new for some, but 10 frames are awesome, and we're going to use them a lot in kindergarten, first grade, because they help develop place value. Students can start to see number relationships and patterns, especially when we start to add to 10, or when we use double 10 frames, so when we want to add to 20. And it helps them count because they can visually start to see patterns, what 3 looks like, what 4 looks like, what 8 looks like. Or how about 9 down in the right-hand corner? Well, they can quickly see that 1 is missing, so there must be 9 there. So they're adding and subtracting and noticing patterns without actually knowing that that's what they're doing. So let's talk a little bit more about the relationship between equality here. So I've got 2 students that set up their cubes as follows. And you might ask the questions, what does the shape on the left look like to you? And students can use their imagination. Again, there's no right or wrong answers. Count how many there are. Well, how do you know that's how many there are? So a student would count 1, 2, 3, 4, 5. Well, I know there are 5 there because the number stops at 5. And then it's also key to practice writing. So the student would write 5 below. What does the shape on the right look like to you? So they may say a letter, they may say some other figure. We'll count how many there are. So a student would count 1, 2, 3, 4, 5. Well, how do you know that's how many there are? Again, because I can, we stopped counting at 5, there must be 5 there. So then again, we would write 5 below it. Others, how are the shapes alike? How are the shapes different? So compare and contrast is also important because although their shapes are different, they still contain 5 objects. So let's say I have these clip cubes together here, and I can say that there are 5 red ones and count that there are 5 green ones. We can also talk about position. So when I look at the red cubes starting on the left, we have first, second, third, fourth, fifth. And we can do the same with the green cubes. First, second, third, fourth, and fifth. Then what if I take one of my green, unclip it, and click it to the bottom of my red train? I can ask questions like, what is the color of the first cube? Well, the first cube, when I count first, second, third, etc., is green. What is the color of the last cube? The color is red. What color is the fifth cube? So then students would have to count first, second, third, fourth, fifth. I see the fifth cube is red. Let's say that we put them back together. Let's replace the second and the fourth red cube with green cubes. So giving the students a moment, they're going to have to decompose and recompose the numbers in order to do this. So I look and I replace the second cube with the green. So I have first, second, third, in the fourth position I need a green, and then I can stack the rest of my 5 cubes on top. Flip it over. Are the second and fourth cubes green as well? Well, we see when I flip it over, when I count from the left again, first, second, the second is a red cube. Third, fourth, the fourth one is a green cube. Fifth, sixth, but in this situation, the sixth one is green, which answers what are the positions of the green cubes. So let's also say I have a set of pattern blocks here, and let's line them up in a one-to-one correspondence such that there is one yellow square for each blue diamond. So I did that for us here. And let's count them. So I have 1, 2, 3, 4, 5, 6, 7, 8 yellows. So I wrote 8 next to it. And I have 1, 2, 3, 4, 5, 6, 7 blues, which I wrote next to it as well. Determine which group has more and explain how you know. So I'm going to take away 1 yellow and 1 blue set until we don't do that any longer because we don't have an equivalent amount left. And we will see that there is 1 yellow remaining. So therefore, there must be more yellow than there are blue because we had 1 left over.